Welcome to the Cannabis Cultivation and Science Podcast. I'm your host, Tad Hussey of KISS Organics. This is the podcast where we discuss the cutting edge of growing from a science-based perspective and draw on top experts from around the industry to share their wisdom and knowledge. Just a friendly reminder for folks who enjoy the podcast content and want to support the podcast, we have a Patreon where we do a book club, hangouts, and share private content that we don't share on social media. We also offer a wider range of products ranging from living soils, LED lighting, beneficial insects, organic fertilizers, and professional consulting on the KISS Organics website. My guest this week is June Graesch. Julie has 18 years of experience as a biological scientist, practiced in laboratory, greenhouse, and field research, as well as technical service support for the integrated pest management industry. She has been with Bioworks for 5 years and has previously held positions at BASF, Becker Underwood, and Iowa State University. Now on to the show. Morning, Julie. Thanks for coming on the show today.
Thank you very much, Tad, for having me.
Yeah, I felt so fortunate to have met you at a couple trade shows now. I know you're a good friend of Suzanne Wainwright Evans, who's also a good friend of mine, and she speaks so highly of you. So I'm very excited we managed to figure out a time to get you on the podcast.
Well, thank you very much. Yes, Suzanne is a fantastic friend of mine, and we talk about everything professionally, but also a lot of personal stuff too. So we're very good friends, and it's just great to be here. And in addition, with Suzanne, we the other good thing is we talk a lot about challenges that growers are having in the field, and we bounce ideas off of each other, and we'll look for research together to solve particular problems. And so we're very much a team in that sense in trying to come up with the best solutions for growers.
Yeah, let's give listeners a quick intro into your background and how you came into this role at Bioworks.
So I've been with Bioworks since June of 2019. So that's for about 4 years, I think. And I should have done the math on that. It's been a little while since I looked. But so right before COVID. And at Bioworks, I started off as a biological program manager responsible for our insect management portfolio. And last year, we had some rearranging of our technical services department, and I switched roles to a technical services manager. And so I am a more generalist instead of just focusing on the insect side of things. I also help growers with the disease management and plant nutrition to a lesser extent. It's definitely not where my strength lies, but I can speak to it a little bit. But diseases and insects are where my passion lies. So in terms of what I do as a technical services manager, we have a tech emails and phone calls hotline that we always have someone on there paying attention to any calls and emails that come in. And so I help out with that. And we also go and visit growers in the field. I work also very closely with our regulatory, marketing, research and development departments internally to bring new products to the market and improve on the products that we currently have in the market. So I wear a lot of hats in that sense, and help out where I can and when I can. But my main priority is working with the growers and helping them solve disease and arthropod issues that they're dealing with. As far as my history prior to Bioworks, I was with BASF and I was in seed solutions. So I mainly did a lot of work on corn, soybeans, wheat, and cotton. But I had a research greenhouse where I uh, treated seeds and then planted those seeds into the greenhouse and then infected those plants with soybean cyst nematodes or with corn rootworm to see how the seed treatments performed on those insects. So it was still insect focused, even though it was in seed solutions. BASF bought the company that I was working for originally called Becker Underwood. And I was with Becker Underwood for about 6 years and with BASF for about 7 years. At Becker Underwood, I was in quality control, regulatory, and I was also a nematode field development specialist where I worked specifically with the beneficial nematodes, very much doing the same thing that I am doing now, but focused specifically on beneficial nematodes. So I do have a lot of experience working with many of the nematode species that are commercially produced and used by growers. So that's pretty much me in a nutshell.
Great, great. And for folks that are listening, if you are interested, you can also check out the podcast I've done with Chris Hayes and Michael Brownbridge, who are both also at Bioworks and offer a really unique perspective around talking about pathogens and insect control and pest management, things like that. So those podcasts were recorded a while ago, so people can check that out. Well, why don't we start off talking about nematodes, since you do have a background in this. Now, I myself have only used SF nematodes, and I tend to say SF because I always mispronounce the name. Maybe you could start off talking a little bit about SF nematodes and what they treat, and because I found them to be very effective, and then maybe what other commercially reared nematodes might a cannabis grower consider in their program.
Excellent questions. So SF stands for Steinernema and Steinernema is probably one of the most common nematodes that you buy. And it is often considered a specialist in some fly species, and it is very commonly used for fungus gnat management. Steinernema is also used for thrips management. So thrips pupa that fall pre-pupa and pupa. And it's important to note that not all thrips pupate in the soil. So if you are going to use nematodes, Steinernema or Steinernema carpocapsae, for management of thrips, you do need to make sure that you identify the thrip species that you have and confirm if that thrip species is in fact pupating in the soil. Because if it's not, you can throw all of the beneficials in the soil that you want, and it's not going to work because they're pupating on the plant. Thrips are an interesting species in that they are sort of an intermediate between a complete and an incomplete metamorphosis. The pupa still kind of have legs, and if you poke them, they can actually still move around, which is unlike what you would think of when you think of a pupa. So that's why we kind of consider thrips as, you know, an oddball in that it has this odd intermediate stage. So that being said, that's why the pupa can sometimes will stay on the plant because, again, they still have legs to grip onto the plant. So there are a few species of thrips that do continue to pupate on the plant, one of those being echinothrips, are a good example of a thrips that would pupate on the plant. Now something like an onion or a western flower thrip, onion probably being the more common species in cannabis and hemp, are often pupating in the soil. If you have a really thick, say flower or bud, sometimes they may get stuck in those and not come out and pupate in those, but for the most part they're going to drop to the soil. So then you can use beneficial nematodes. There are also a couple of other soil-based beneficials, such as Stratiolaelaps and Dolocia, which are predatory mite in the case of Stratiolaelaps, and Dolocia is a beetle. And they do fly at night. So I know that Dolocia isn't something that a lot of cannabis growers use because they might not want to get that in their bud. So, with that being said, there are a couple of beneficials that are used for fungus gnat management. One of those being Steinernema. And I will tell you that there is research, probably the most research has been done on Steinernema and Steinernema. And Steinernema it can also be used for management of thrips and fungus gnats. There is research that suggests that both of those are okay to use. Traditionally, we use Steinernema because we have seen really good management with that nematode species. And it can be, both of those species are fairly robust nematodes. So basically what happens is if you were going to use nematodes for management of, say, let's say fungus gnats, really fungus gnats or thrips, say you had onion or western flower thrips, and you have fungus gnats, which is very common. These are very, very common insect species that happen almost ubiquitously across all operations. And so if you were going to use Steinernema, there are a number of companies that sell nematodes, and they can come in a variety of formulations. That's a much longer conversation that, if we want to go down that path, we can. But basically, there's a number of formulations and a number of ways that the nematodes may come to you. Sometimes they come in bags, sometimes they come in trays. But in almost all cases, it's either crumbly or more of a sugar cookie batter consistency. And you'll want to keep those in the refrigerator because those nematodes are in an infective juvenile stage, and all of them that you receive are infective juveniles. All of the other life stages are going to occur in an insect host. So those infective juveniles, their only way to survive is if they find a host. So they're very driven to find this host. And if they don't find a host, they die because they are a very specific life stage in the beneficial nematode life cycle, where they are free living, meaning that they're found outside of the host. All of the other life stages of the nematode are inside the host. So that's important to know because this adaptation of the infective juvenile, they retain the molt from the previous juvenile nematode, and that sort of creates this jacket on the nematode that helps it, when it's outside of the host, prevent or at least decrease the chances of quick desiccation or drying out. So it kind of creates this jacket of protection. And in fact, it may also help with compatibility because we've got a lot of compatibility results out there with a number of the nematode companies will provide compatibility with tank mixes that you can apply with the nematodes. And nematodes are fairly compatible with a number of chemistries and biologicals.
Can you give an example of something that you may want to tank mix with a nematode if you're doing an application? There are the more common ones, maybe in cannabis.
So another pest that is commonly found in cannabis and hemp is the rice root aphid, and the rice root aphid is a tough one to control once you get it. So obviously sanitation and quarantine are incredibly important. Again, we don't want to necessarily go down that rabbit hole unless we want to, but if you were many growers use entomopathogenic fungus for management of rice root aphids. Entomopathogenic fungus, genus species Bavaria bassiana, Isaria, Formosa rosea. The Isaria has now been renamed, by the way, to cordyceps. So if you see cordyceps, it is now the new Isaria, but you'll see it sometimes interchangeably, but the new language is cordyceps. So Isaria/cordyceps. There's also a number of metarhiziums, which is another entomopathogenic fungus. So those are the three main fungal entomopathogens that are used by growers. And each one of those are, they're good products. There's a number of companies that sell a number of these products. Sometimes the same genus species, but different strains. And they're all pretty good at management of various soil and foliar-based insects. So to get back to your question, Tad, you could tank mix if you also had rice root aphid. You could tank mix your nematodes with one of the Bavaria metarhiziums or cordyceps species, and then you would be targeting more pests, basically. And sometimes those are going to work synergistically together. So, for instance, the entomopathogenic fungus. And entomopathogenic simply means insect killing, by the way. And sometimes the beneficial nematodes, although that's the easier way to say it, technically they're entomopathogenic nematodes. So both of these are insect killing fungus and insect killing nematodes. So you could tank mix these two species. You may get additional benefits in management of your thrips and the fungus gnats. These entomopathogenic fungus are typically not that specific. So we often have labeled pests, but you can get additional efficacy by using some of the entomopathogens. So that would be one obvious one. I know that azadirachtin is a good one to use with your entomopathogenic fungus or the entomopathogenic nematodes. There's often synergy or additive effects. I know that not all cannabis growers will use azadirachtin. Insect growth regulators in general are a good thing to pair with nematodes and fungus because it will slow down or stop the life cycle, and which is incredibly important if you're dealing with aphids or other arthropods that have very fast life cycles, because the fungus takes typically 24 to 48 hours to adhere to the surface of the cuticle, to germinate, to put out the aposorium, which is the infection body that creates the metabolites and pressure that punches into the insect's cuticle, and then that hyphae goes down into the insect's hemocoel or blood and then kills the insect. So that process to get into the insect typically takes 24 to 48 hours. So let's say you apply one of the fungal-based products. Any aphid that molts within that 24 to 48 hour period may not be killed because they are shedding off those spores, and they don't move around very much, aphids specifically. So they're not going to crawl around and get more spores typically. So what you apply initially is oftentimes going to be what you're going to contact them with. So if you can slow down the insect's life cycle with an insect growth regulator, it will very, very commonly have higher efficacy when targeting pests like aphids, thrips, whiteflies.
So, just to make sure, just to reiterate, you're saying using a product like something that has azadirachtin, like maybe like Azagard or Azamax is brands that I'm familiar with. I'm sure there's others out there on the market. So something azadirachtin based, and then looking at a Bavaria product. You obviously with Bioworks, you guys have Botanigard. I'm also familiar with Bioceres is another Bavaria product potentially people could look at, and then combining those two along with a nematode, and you specifically SF nematodes or Steinernema carpocapsae, if I said that somewhat close.
Very close.
Okay, that's really interesting. So one thing I wanted to touch on with you, and we talked about this a little ahead of time, was this is something that I learned from Suzanne that I think is really important to highlight, and that's that these different species are within, let me back up, within like Bavaria. Let's take Bavaria as an example of this. Bioworks through Botanigard has a very specific species of or strain of Bavaria bassiana, and that's what gets commercially reproduced. They discovered it, and it has very unique special properties to it, and that's why it's so successful, because it can survive in a variety of different media, different temperatures. But it's going to be different than, say, the product from Bioceres or another company. It's going to be a different strain or species of fungi. Also Bavaria bassiana, but getting to the idea that not all Bavaria is the same. So just because and this is the same for mycorrhizal fungi, this is the same for, as far as I understand, pretty much all of these beneficial microbial products. And so growers may want to, rather than saying Bavaria doesn't work or Bavaria does work, they need to find they need to try maybe a couple different brands to figure out what works in their environment, depending on what sort of biotic and abiotic factors they may have in their cultivation facility or space. Is there anything you want to add to that or touch on in regards to that?
Yes, I have a number of things to add. So first I want to mention that Botanigard is no longer sold by Bioworks.
Oh,
it's
I
now
apologize.
actually nope, it's fine.
That.
It's now marketed by OHP. However, this year we are planning on launching our own product, and we hope to do that at Cultivate. We're still waiting on our EPA registration, which should be soon. So with that being said, so let's talk about a few of the products that are on the market. There is Botanigard, which is a Bavaria bassiana strain GHA. There is Bioceres, that is ANTO3 strain. There is Velifer, which is PPRI 5339 strain. And then those are the main ones, at least those are the ones that are that come to the top of the mind. Our strain that we are going to be commercializing is also a Bavaria bassiana. So all of these are Bavaria bassiana species, but they're different strains. So what I'll say about that is oftentimes all of these different strains have been isolated initially from an insect. So researchers in the field, they see these mycost or fuzzy bugs, that's all the mycelium and the spores that are produced, and they take those mycost insects into the lab and they culture them, and since they were on a bug, in the field, is that something that's just advantageous fungus, or is that something that actually killed the bug? So they will take those spores that they get from their culturing and try to infect other bugs. And if they kill, then it's likely that it is an entomopathogenic fungus. And, again, there are a ton out there. These are just the ones, and there's a lot more that is known than is commercialized, for a number of reasons. Mainly, are these particular fungal strains capable of being mass produced? And not all of them are. So, for instance, with the Botanigard being a GHA, GHA actually stands for grasshopper A. So that was isolated initially from grasshopper. Some of the other ones, no fly. No fly is another one. That's that's cordyceps though. So Isaria. So I'm getting a little off base, but similar concept. So let's just continue on with the Bavarias. So all of these different Bavarias were isolated from different insects. So sometimes we can see improved efficacy on, say, the tarnished plant bug. I think I'd have to go and look how ANTO3 was isolated. I want to say that was from a plant bug, but again, I haven't looked recently, so don't quote me on that. But you can have strengths and weaknesses from all of your fungal strains. So oftentimes I will tell growers that you don't necessarily have to use just one. You could have a couple of the fungal strains in your arsenal within the same genus species, but you could also have within the same gene, in a different genus. So Bavaria, Isaria, cordyceps, or Metarhizium. So you could rotate, say, a Bavaria with a cordyceps, or a Bavaria with a Metarhizium. And again, each one of those individual fungal genus, species, and strains are going to have different strengths and weaknesses. And so you can have you can get potentially more out of your entomopathogens by rotating them, which is generally a good strategy to have.
So, well, first off, thanks for correcting me on that. I had known that about Botanigard, and I just completely spaced in the moment. But I'm excited that Bioworks is going to have their own product or strain coming out very soon. I look forward to hearing about that. I currently have in my indoor garden, I have the granulated Bioceres product as well as their liquid product. And so I would suggest for growers, the ones that you listed is a good starting point for people in terms of looking for commercially produced, high quality options. And I only say this because I know there's some other ones out there that Michael Brownbridge has tested in conjunction with Suzanne, that either I think it was a Metarhizium product that had claims of spores that was higher than physically possible to fit into a container, as well as another one that had spore count so low that there was no way you could get efficacy with it. Because I know I could source Bavaria from China right now. I could buy it, get it shipped in, and sell it. But it's probably doesn't have the same efficacy or quality that we would want to use in our garden, as well as potentially containing heavy metals, other microbial contamination, and other issues. So I would just caution listeners to make sure you go with a company that's done a lot of research and has a good reputation in the industry for these specific products.
Excellent point. So in addition to everything that Tad just said, so the products that I've mentioned, so that's the Botanigard, the Bioceres, Valifer, Botanigard, the Lalagard M52, the Isaria or Cordyceps products, no fly, Icerid, so on and so forth. Those are all EPA registered, Environmental Protection Agency. And in order to get registration, you have to have a lot of uh, ecological toxicity, and to know how it's going to behave or break down in the environment, and if there is any harm to, say, humans. And it goes through all of that testing. There's also a lot of quality testing that goes on to make sure that quality standards are met when these fungal products are produced. And lots of data that went behind knowing that these particular genus, species, and strains are highly efficacious to the pests that are labeled. Now, when you bring in a product from China or from, some of these other countries that are offering these microbes, there is no guarantee that what they say is in that container is actually in that container. Tad mentioned microbial contamination. There could be human pathogens in those formulations. They've come from overseas and probably not refrigerated. And so as those spores die off, it could then be a breeding ground for bacteria and other fungus. And so who knows what you're applying. So I would, as Tad mentioned, be very cautious about bringing something like that into your facility. Use the EPA registered products. They may cost you a little bit more than the ones that you get, but it has valid data behind it, backing it, and you know that you will get a good result where you don't have that with the off market, not off market, but black market microbes, which we sometimes call them.
They
The
are
other thing
technically
that
black market because they're not
they truly
legally allowed to be sold in the U.S., but they are.
and that's the other thing.
Yeah.
And that's the other thing. Yeah. You also mentioned about formulation, and I think that's important to mention with the enema pathogen fungus specifically. So there's granules, there's liquids, and there's wettable powders. So those are the three most common formulations, with probably the wettable powder typically being the most commonly used. And I would say that that's probably the most common because, well, it's got a lot of proven efficacy, but it's got really good crop tolerance profiles too. Wettable powders are very crop safe, typically. The other one that's probably the second most common is a liquid, and that can be in typically an oil-based formulation. You don't want to have water in your formulation because that will make the spores germinate. So in oil that has very low water content, think honey, basically. That honey has very low water content. Oils typically have very low water content, so you can formulate in oils. Some of those formulations are going to be horticultural mineral oil based, and some of those are going to be seed oil based. Sometimes you'll see that as a OD, oil dispersion. Sometimes it's an ES, emulsifiable concentrate or suspension. But basically those are liquid formulations, and those are really, really good formulations to use, especially outdoors, because you have some rain fastness with that you typically don't with a wettable powder. So there are strengths and weaknesses. Now, you want to be careful by putting oil in, say, the roots. So if or the media where the roots are, because you don't want to suffocate the roots. And there are some formulations that are labeled for drench, and in which case that's something that you may get additional efficacy with. So make sure that it's labeled for the particular application that you want to do. But the liquid formulations are excellent in that in addition to the efficacy you get from the fungus, you also get additional efficacy from typically suffocation. So you get a couple of different mode of actions with the oil-based formulations. The last one that I will mention is the granule formulation. And we had them on the market, and then for a while we didn't have them, and now they're starting to come back again. And I think the granule based formulations are of enema pathogenic fungus are fantastic, especially if you are targeting insects in the soil, indoor or outdoor, because basically when you pot up your media, you are incorporating these granules into the media, and now they're basically landmines in there, and those as insects come into the soil profile or are moving around potentially in the soil profile, they'll encounter these balls of spores and get infected with them. As you water, those spores will also disseminate throughout the soil. And the other benefit to having a granule formulation in the soil is, especially if you have a lot of microbes in your soil. You know, we talk a lot now about regenerative soil, and having all those microbes in the soil that have a healthy soil environment. With all of the things that you could have in those soils, you can also have potentially, depending on what's in there, in inhibition effects. So something that may cause Bavaria or a fungus to not germinate. So with that being said, with a granule, the granule typically has some sort of food associated with it, whether it is a rice grain that rice is no longer alive, so you don't have to worry, or a millet. Those seeds are no longer alive, but it's food for the fungus. And so by having that food source available as in that granule, the if there are microbes that are now competing for resources and space, by having that food source in the granule, you actually get that fungus is able to then outcompete many of the other soil microbes, at least in its general vicinity, so that you can get increased efficacy. It's also longevity wise. If you did a wettable powder drench, and there are studies, there's a study by trying to think of out of Vermont, there was a study that was done where the researcher did a drench of wettable powder versus the granule formulation, and they got good efficacy from both, but they found that longevity wise the granules lasted a lot longer than the wettable powder, because
What was
again,
the target insect in that study? Do you remember?
You know what? I don't remember what the target insect was. I
Okay.
think it might have been thrips. Um, and Tad, I can get you that a copy of that study if you're
Yeah, I think listeners might find that interesting.
if
I know that, like from talking to Suzanne, one of the things she was most excited about, which got me excited, was using the granule formulations. And I had specifically, like I said, I have the one from Bioceres, and that would be used for treating root aphid. Now, I don't have root aphid in my garden currently, but I am incorporating a little bit of the granules in at transplant. Yes, root aphids are the worst. As a precautionary, preventative for like thrips, and I believe it works on fungus gnats as well. So it's just a really easy formulation to work with. And that idea of increased persistence, or also the idea that when you have a pot that has holes on the bottom, knowing that those root aphids can reach those holes at the bottom, it's really hard to get spores all the way down there and good efficacy when you're doing a drench. So I think this is where these granules could really shine as a formulation option for folks. I would love to see these companies, and I'm gonna throw Bioworks under the bus here too. I would love to see them come up with smaller sizing, because it's so hard as a home grower, whether for my vegetable garden or for my indoor garden, to find products in sizings that make the sort of sense that I can use them. It's really tough.
I hear you, and we do get that question quite a bit. And so these commercial formulations, again, because they're EPA registered, they have very strict label language requirements, and personal protective equipment, and very strict use requirements and reapplication intervals. And because of all of that, it can be more challenging to sell that to the homeowner or the small grower, because they may not have the understanding that the label is the law. And that's why oftentimes in, say, Home Depot, you still have products that, like 7, that you can buy off of the shelf that have these same active ingredients that we use in commercial operations. However, if you look at the active ingredient concentration, it's very often significantly less than what you would get in, these EPA registered products that are sold to large operations. So that's part, I think, of why you don't see as much of the companies supplying to homeowners. Now, with that being said, there is, I don't know if there are distributors that do cater to homeowners and smaller growers, and do offer smaller pack sizes, or not case quantities. So there are some options out there. Just remember that if you're going to be using a microbial or a live organism like a nematode or a fungus or a bacteria, that if you're buying those off, say, Amazon or something like that, you and the manufacturing companies don't know how those products necessarily have been stored, or if the shelf life has been, expired. So you may get expired product. Now, I'm not saying that you will, but I'm just cautioning you that if you are going to buy a live product, please consider going through a distributor that is reputable in the sense of they know how to handle, store, and ship these live organisms. So that means that you get the best possible product that will kill the arthropods or diseases that you are targeting. Because a dead nematode or a dead fungus or bacteria is not going to control your pest populations. So it is important on how it's stored and shipped.
Yeah, that's something that Suzanne's really drilled in my head on the insect side. We now offer insects through BioBee, but we ship everything overnight directly from the insectary, so we never touch it. And I know on the insect side, some folks are repacking into smaller quantities for homeowners, which is nice, but that can also impact the quality and efficacy of the actual product when it arrives. So I'm glad you brought that up. And one thing I learned with nematodes, and maybe you can validate this or tell me it's wrong, but essentially the reason these quantities are so high with the nematodes is there's sort of a critical mass, like kind of like a compost pile. There's a minimum needed to maintain the viability that we want. So that's why they're sold in these, fairly large quantities. Is that accurate?
So with nematodes, there is a ton of research out there on a plethora of arthropods, and the research tip that has been conducted are using a quantity of nematodes to kill said pest. And so the rates that we're recommending for nematodes are based on research results. And I would say for the in vitro produced nematodes, or nematodes that are produced in, say, fermentation, those the rates for those types of nematodes are typically in the 1 billion nematodes per acre rate. Sometimes less, sometimes more, again, depending on the species of pest that you're targeting. So I'll use, for an example, there is a nematode, I would say lesser known, but still very commonly used, called Heterorhabditis bacteriophora. It is a nematode that is very commonly available and can work better on, say, beetles. It's a good beetle nematode species. So there are a couple of beetles on the label. So Japanese beetle is one that many of us are familiar with, and those beetles, the grubs, are easier to kill than, say, a European chafer. So with a Japanese beetle, we're going at a billion, half to 1 billion nematodes per acre, versus a European chafer that may go up to 4 billion per acre. So the reason why you see differences in rate are often, again, goes back to the research in how many nematodes were required to kill that particular pest. So a nematode, an infected juvenile, you apply via spray. Broadcast is best. Dripper can work, but you have a single point, and those nematodes then need to go out from there. So it can still work, but you need to provide the moisture for them to move. So it contacts let's say the Japanese beetle grub, and really insert pest here. I'm using beetles as an example, but so if that particular pest does not recognize that nematode as self, then that you only really need a couple of nematodes to get in to overwhelm its immune system. Nematodes also carry a bacteria, and in the case of Steinernema, they regurgitate that bacteria, and it's actually the bacteria that does the killing of the insect. It multiplies, and then the nematodes are actually eating the bacteria, and that was killed by the bacteria. So and then Heterorhabditis nematodes actually defecate or regurgitate the bacteria into the insect. So you need a couple of nematodes to get in, say, that Japanese beetle, to release that bacteria. It may not recognize that there is an invasion going on, and pretty soon it goes through septicemia, blood poisoning because of the bacteria, and it dies. Now, let's say the European chafer, it does recognize the fact that, oh, I am being infected by nematodes, and it will launch an immune response that is much stronger. So you have to have a lot more nematodes being applied to the soil in order to overwhelm that particular insect, or in this case grub, immune system to kill that insect. So that's why you see the difference in rate with nematodes. And again, typically with the rate being around 1 billion nematodes per acre. Now, obviously, that's per acre, so sometimes on labels you'll see that more in the per 1,000 square feet. But if you work that up to acre, it's going to be in that general vicinity.
That's really interesting. I wasn't aware that it was the bacteria. So the nematode. Take me through that. The nematode penetrates the grub, the skin of the grub essentially, and then deposits the bacteria, and then the bacteria reproduces, and then it re-eats the bacteria. Is that essentially what you're saying?
That is essentially what I'm saying. So, for Steiner nematodes, they have to enter through natural body openings. And so that's the mouth, the anus, and the sphericals. And then once in, they release the bacteria. They shed that jacket that we talked about earlier. They release the bacteria, and then the bacteria kills the host. Then the soup that is produced from the death of that insect will be the food source for the nematodes to go through a couple of generations of nematodes inside the particular host. The larger the host, the more generations. The smaller the host, the fewer generations. So once food starts to become limited, that next generation of nematodes, instead of going into the next juvenile stage, will then, once the food is limited, will go into the infective juvenile stage. And that's the stage that leaves the host in search of more hosts. So that's basically the life cycle of general life cycle of the nematode. That would go for both Steiner nema as well as Heterorhabditis. I will tell you though that Heterorhabditis nematodes also have a hook on the end of their nose or their body, and for insects with very thin cuticles, they can actually direct penetrate into, say, a grub, because a grub would have a very thin cuticle, and so you have direct penetration, which may be why we see it being a little bit better for, say, grubs than, say, a Steiner nema would be, that would have to go through the mouth, the anus, or the sphericals. Then there's also, I mean, if you want to get into all the different nematodes, we've talked about three. So we have Steiner nema feltii, we have Steiner nema carpocapsae, and we have Heterorhabditis bacteriophora. The other really cool thing about nematodes is they have different foraging strategies. So starting with Heterorhabditis, they are what we call a cruiser, and they are a very active nematode. You put them into the soil and they go crazy using up their energy until they find that host, or they don't and they die. Or they continue on their life cycle in a host. So they're go, go, go nematodes. Then we have Steiner nema carpocapsae that have an ambush foraging strategy. So they're a nematode that has been adapted to the surface of the soil, and you find them in the upper soil layer and the soil surface, and they're going after more of your mobile insects that are going to be on the soil surface or in that upper layer. And what they can do this thing where they can actually lift their bodies up off of the substrate, and they sort of wave around. And if they sense a host that's coming either through vibrations or through volatile cues that are given off by the insects, and they sort of curl themselves up into a ball, and they can flick themselves at their host to improve their success into contacting that host. That's called nictation, and that's done by our ambush nematodes. So if you're going after a pest that is a surface pest, you might want to, pick Steinernema carpocapsae, because in addition to what I just said, they are also a little bit more desiccation tolerant and sometimes also heat tolerant. John Sanderson from Cornell, who just retired, did a study on these nematodes and found that carpocapsae is a little bit more heat tolerant than, say, Steinernema feltii. Now, finally, Steinernema feltii is an intermediate. So its foraging strategy is somewhere in between that of the cruiser and the ambusher. It's also a very large nematode, whereas Steinernema carpocapsae is a much smaller nematode. And so you can have Steinernema feltii sort of hanging out or cruising around for a host. So typically you'll find that in the upper soil profile, but typically much lower in the soil than, say, that of carpocapsae. And your Heterorhabditis nematodes, with it being very active, has the largest range where you may find it throughout that soil profile. That is a little bit more in potentially in nature. Obviously, when you're growing in pots, the type of media does have a big impact. The more dense and say compact the soil, the harder the nematodes get through that. But if you had, say, a cocoa coir, that's or a peat-based media or mixture, as many of us do, that is a really an excellent media to use beneficial nematodes in, as well as the beneficial fungus that we talked about. That's also a good media. You can also use nematodes and fungus in, say, a rock wool or oasis. However, the spores don't live as long, and the nematodes will often get pushed out from subsequent waterings. So you do have to do more frequent waterings, more frequent applications in that type of media than if you were in the soilless based media and those type of medias. So yeah.
That was really interesting, because I was going to ask you, how the heck do these nematodes survive if, most of their life cycle is inside an insect? How in nature are they surviving? And is there any way we can apply that, knowledge to, say, an indoor, environment, CEA environment, where we don't have, we're trying to kill off all insect hosts, and then I assume the persistence is not great in terms of these nematodes surviving beyond the initial application very long. What are your thoughts on that? And then I have a couple other nematode questions, since we seem to be going down the nematode and entomopathic fungi rabbit hole here, and I'm gonna have to have you back on, I think, to ask you the actual bulk of the questions that I'd originally planned for this episode. So let's just stick with the nematodes for now. What are your thoughts on that?
So, nematode survival. So, the biggest factor, I think, in nematode survival is to make sure that you give them enough soil moisture in order to not only survive but move in that soil profile. You don't want to have, say, a lot of flushing and a lot of that water that the subsequent waterings where you have a lot of water that's coming out the bottom of the pot after, a nematode application, because you could be pushing them through, especially if you have, say, a pure cocoa coir. That's a pretty porous media, and you could wash them out. So think about your waterings. Obviously, you still want to water, but not to the point of a lot of run through the pot. And in terms of survival, as long as they have moisture and you don't dry it out, they're going to do their thing. They're going to search for hosts and either find them and infect or perish, because they only have, as they are feeding in the host, they are gaining the lipids or the fats that they need in order to find a host. And so they only have a finite storage of their lipids. So once that's run out, the nematode no longer has energy to move on, and it will die. So the faster those nematodes can find hosts, the better, which is why doing a broadcast application to, get those nematodes all over in the pot, and then down from there, is generally a better strategy than doing drip irrigation, and where they get in one spot and then they have to move out from there. They will, but it will take longer to get to those, outside areas of the pot where a lot of the fungus gnats are. So just that's a good application tip. Did I answer that question, or
a couple things? So
what was it again?
I think application method is important to probably touch on. Like I had to lean heavily on Suzanne for this, and I know you're looking at this at a very much larger scale. But I know that there's there's people like myself that are also using them in home gardens or houseplants or situations where we don't have a nematode bucket like that cool product from Dram that's going to keep everything agitated and stirred without heating it up and killing the nematodes. So
I helped them develop that system.
Oh, you did? Oh, Julie, that's so cool. I had no idea. Yes, so if you're a commercial facility that's using a lot of nematodes, absolutely check out the nematode bucket from Dram. It's a very cool product. It looks very simple, but it's actually quite complicated because you're trying to keep them in suspension evenly, but also not allow any extra heat to end up in it, correct?
And yes, and may I mention that it's not just used for nematodes, but if you're doing irrigation injection, you could put your enema pathogenic fungus in there. You could do your nematodes. You could do many of your other applications, and there is a swirling factor, but you can also turn on air that will increase the oxygen in the water. Nematodes aren't aquatic, so eventually they do drown, especially if you don't have agitation. They fall to the bottom of the tank. They're all still consuming oxygen in the water, so if they don't have oxygen, then that's a really good way to kill them. Also, cold water holds more oxygen than warm water, and so it's very important to keep those solutions as cool as possible and apply them as quickly as possible so that those solutions don't heat up over time.
So I actually just did a podcast interview I haven't released yet. It'll come out before this one, but with Les over at Dram talking about dissolved oxygen specifically, because it is an important topic. And yes, temperature plays a huge role in dissolved oxygen capabilities of water. So what I did, and you can correct this, but essentially I took the nematodes out of the fridge. I let them warm up a little bit in the room for a couple hours. I then added some water to just a watering can, because just to give you an idea, I have two 4x4 beds that I use for sort of a test garden here at my house. I filled up a watering can with a little bit of water, and then I added the nematodes, stirred them all in, added a little more water on top. I made sure that water was just comfortable. Maybe it might have been a little bit too warm. Now, in retrospect, I might have been able to go a little bit colder, but I also didn't want to pour a bunch of cold water on my soil, knowing that I have plants in there that, you don't want to shock the plants with cold water either. So I then applied, it took me about 5 minutes to apply my nematodes, just stirring and dumping it out, making sure to cover as much of the surface of the soil as possible. And so I did this last cycle in the room, and I knew that the clones that I had came in with thrips. Not a lot, but there was some damage, and the grower who I got them from pretty much warned me. He's like, "Oh, by the way, I did not know, but I gave you thrips." So I released some row beetles, I believe some strats, and then also the nematodes. And I did not see any thrips damage throughout that cycle. But in regards to the nematodes, how is that as just a real basic application method for home growers? Are there any sprayers that we need to watch out for when if we were to put it through a sprayer rather than just the watering can method? Sorry, I just threw a bunch of questions.
Probably for your homeowner or small grower based application equipment, it shouldn't be an issue. Like your simple Venturi type water displacement sprayer, like a hose end sprayer. That's a pretty good method for applying beneficial nematodes. It's a little bit harder to control the amount that you're applying in that type of system. So you want to be aware of that. But that's a good system. Basically, the biggest thing to be aware of with nematodes, temperature, which we talked about. If there are filters in the system that the nematodes will pass through, they tend to get caught up on filters of 50 mesh or finer. And so during the nematode application, you want to remove those filters or put in a larger filter size. So that they don't get caught up and shred. And also PSI pressure. You just don't want to go over 300 PSI. As long as you're below 300 PSI, which typically isn't a problem, then the nematode should be fine. Basically, in the system, they're subjected to a lot of pressure. And if, say, it's above 300 and then they go through the nozzle, and they go from very high to very low pressure, that is detrimental to them. So as long as you're below 300 PSI, should be fine. And I would say the last thing is you don't want to have like a mist nozzle on there. You want to have a nozzle that's large enough that you have, especially since we're applying it to the soil, typically. So you want to have a larger nozzle on your sprayer so that those nematodes can freely pass through and get into the soil with the moisture that you're applying.
Now, what about a one-time pass through like an impeller pump, like a sump pump? If I had like a 50-gallon garbage can filled with water and I added the nematodes to that and then applied that through a hose end sprayer with either a very simple spray gun on the end of that hose, or even just my thumb and finger over the end, like how is that as an option?
So I actually did a study back in my Becker Underwood days where I did the difference between no agitation, aeration, and basically the bilge pump. So an impeller that is swirling the water around. And obviously the worst option is the no agitation because everything falls to the bottom. If it takes you a while to apply that, the nematodes are all sinking to the bottom. Typically, your intake is at the bottom. So all of the nematodes get applied first, and very few nematodes get applied at the end of the cycle. So you'll have a bad distribution of the nematodes in the grow or wherever it is that you're applying those nematodes. So that's the worst option. So if it's the difference between having agitation and not have agitation, So with the bilge pump and the aeration, obviously aeration was better, and you had a much longer the nematode stayed viable in that solution for, I think it was an 8-hour period that I did the test, and I was doing I was taking samples at the top of the solution every hour for 8 hours. So with the bilge pump, and this was in a 5-gallon bucket, it did a really great job of keeping the nematodes in solution, and within that first 4 hours, the nematodes still looked good. But that bilge pump that you put into that, in my case, it was a 5-gallon bucket. It is working, and that bilge pump will start to heat up the water over time. So in the study that I did in a 5-gallon bucket, the recommendation was 4 hours or less. So if you can get those nematodes applied within 4 hours using that bilge pump, the nematode should stay viable, assuming that the water temperature is generally staying cool.
Can we throw a
Beyond
number
that,
to quantify
beyond
cool, though? Like 60, 65? Below that? What are you thinking in terms of temperature off
that's
the top
a
of your
great
head? Or
question, and I got. Oh wait, no, it's over here. So,
because I would
so
guess around 60 degrees would be Fahrenheit would be a good temperature range. But what are your thoughts on that?
so nematodes are going to be happiest in the environment. Their ideal range is 54 to 86 degrees Fahrenheit.
Oh,
And so if once you sort of, if you're heating up that water slowly, and not say beating them over the head with with an impeller, it's probably going to be okay. And there's an easy way to check on that, which is pull the nematodes out, take a sample of the solution, and look at the nematodes with a hand lens, or more. Or better, a dissecting microscope. If the nematodes are still squiggling around, it's a pretty easy way to tell if they're viable or not. And if they're not, they're basically pencils. If you see a bunch of pencils, bad things have happened. So, and that's what I saw with my study when it got past that 4-hour mark in the bilge pump. I also measured temperature. I do have a document on this, and I would be happy to share that with you as well, showing the pictures of the nematodes and whatnot
that'd be great.
from this test. And so I'll get that to you. But basically, after that 4-hour mark, the nematodes started going to pencils. And so our recommendation currently is under 4 hours for a bilge impeller type pump. Sometimes with aeration by itself, it sometimes, depending, let's say you just have a single stone in a 5-gallon bucket and that stone isn't very big, you're giving them oxygen, but you're not necessarily getting good agitation. So with the dram bucket, they have both swirling motion as well as aeration. So in your particular operation, you'll just have to do some testing of your particular setup to see if the nematodes are surviving that application. And if you start to see pencils, then start switching up. Apply it faster. Apply with cooler water to begin with, that sort of thing. But you can start to troubleshoot and figure out ways that work best for you.
Great. So it sounds like a one-time pass through an impeller, if we were to use it to do an application, should in theory be fine, but we could test it by just taking a look at the nematodes on the other end. That's great.
Correct.
Well, we've already been talking for a while. Like I said, we didn't even get to I really wanted to talk about EpiShield and sort of what you're seeing in big issues on pest management or pathogen side in cannabis. So I would love to get you back on to talk about those topics sometime here soon.
I would love to come back. I know we didn't even get to talk about oils, which I think was our main goal, other than talking about nematodes and enema pathogenic fungus, which I think we covered quite well. And so if you wanted to have me back, I would be happy to come back and talk about some of the differences between, horticultural mineral oils versus the essential oil-based products, the 25Bs, the difference between a 25B product and an EPA product, all that good stuff. So, Tad, I would love that if you wanted to have me back.
All right. Well, thank you, Julie. I really appreciate your time today, and I will reach out. Talk to you soon.
All right. Great. Thanks, Tad.
That was June Graesch, and you are listening to the Cannabis Cultivation and Science Podcast. If you like the podcast, please leave us a rating and review and give us a follow on Instagram and YouTube. And don't forget, at KISS Organics, we have a wide range of products we offer on our website, ranging from soils, amendments, beneficial insects, soil test analysis, and consulting. Thanks for listening.